Hello friends, welcome you all in the class. So today we are going to discuss about a little bit more about the single linked list. In the previous class we discussed about what do you mean by linked list, what kinds of linked list are, and what are the different operation on. So before going to code the linked list, we must know some basic function for dynamic memory allocation. So we can implement linked list by using so many language you can use as per your convenience. Whatever language you know, you can implement linked list using particular. So if we are using C and if we are using C++, it is some are popular basic language which we can use. You can also use a Python for that. I'm going to discuss on the C because it is a basic thing and generally questions are come from the basic implementation using C programming language. So when we are using the C language, we use some memory management functions like uh, memory management functions. So in C language, there are known memory management function as a calloc, malloc, dealloc, and we can say free. These are some popular functions which are used to declare the memory at runtime. And in C++, there is only two functions for it. One is new and another one is delete. It is a very simple and basic thing. When the word comes dynamic memory allocation, or it is also known as runtime. So in the dynamic, we are using pointer. So what is a pointer? Pointer is a derived data type. It is a special kind of variable because it contains the address of another variable of same type. It is a simple definition of pointer. So with the help of pointer, we can declare the or we can allocate the variable memory at the runtime. So in C programming language, we use these particular functions: malloc, calloc, realloc, and free. The calloc function is used for allocating the same size multiple block. Suppose if you know the definition of array, what is array do? If we are talking about the array, so array contains the collection of similar types. For example, suppose I declare int x of 5. So it contains 5 integers. It means all 5 elements are containing the same data types and same types of size. So in similar, when we are using the calloc, we can declare blocks of same size, multiple blocks. Suppose one block contains size 2. So with the help of this, every block contain the 2 size, and we can declare the multiple block of same size by using the calloc. When we are using the malloc, it used to declare a particular block of any size, any given size, which size you require. You can use calloc to declare that particular variable at a runtime. Realloc, if you wish to modify the allocated size, we can use the realloc. And free, it is used to release the memory which is allocated by any above these functions. When we are talking about the format, so suppose we are talking about the calloc. So calloc, then number of blocks which we required, then size of each block. These are simple format of calloc function, and this particular function runtime reserve the blocks on the memory, and it return the starting address. Starting address of that particular blocks will be written by this calloc function. So when we are receiving this address in particular pointer, we need to typecast it. Typecast it, it means when we are allocating the memory, we need to assign the types of that memory which we are going to use. It means suppose you are using the memory, allocating the memory for integer purpose or a character purpose or something else, then you need to specify that particular type over here. So we need to do the typecasting. See, the typecasting is two types. One is implicit and one other is explicit. Here we are using the explicit typecasting. Similarly, malloc. In malloc, we are simply providing the size of the block. Realloc, in realloc we are providing the pointer, which pointer we use. Then we are providing the new size, what size we are we providing over here. In the free, we simply provide the pointer, which pointer we are using to allocating the memory, and it free the memory. See, it is simply a basic concept. I am explaining it a little bit summarized form because I think that you are already know it. Okay. See, let's going to using that particular methods and declare the dynamically. We are creating the dynamically node. The main purpose is we are using to create the node for the linked list. So when we are creating the node contain the two things. The first one is data part and another one is a next part, that is a link part or that is a pointer part. So it is a heterogeneous collection. So we are using the structure. So struct. Then you need to provide the name of the structure. Suppose I'm giving the name of the structure as a node, and then the data types which we are going to use, variable types. So first of all, I need to use int data. So data is a node struct variable or member, which is a kind of integer. It holds the integer value. I need to take one pointer or next pointer, whatever you wish to give the name. So pointer type is struct node, and then simply I wish to give it name like next pointer, whatever you wish you can give it. Suppose I put to the next. I'm closing the this particular structure. You can also declare the structure variable over here. Suppose I need to declare one pointer start, which is pointing the starting node of the linked list. You can use p for creating the node. You can use tmp pointer as your wish, whatever you can use a name, give the name to the pointer. So I'm like to use this three pointer, and we also assign this start pointer as a null. We assign the pointer start pointer value as a null because initially start is pointing to the not pointing to any particular variable or any particular node. Now we are going to the main function. Don't worry, currently I'm explaining the basic concept, and we will switch to the coding, and I will be writing every code for every operation for the linked list. So now we are going to create a single node. For creating that single node, we need to take a pointer which is a types of that particular node. So here we are using the p because we declare already p, and then we are going to allocate the memory that particular node. So we are using calloc, and sorry, we are using malloc. Calloc for multiple block. We are using malloc for a single block. We need here single block. Need malloc, and then the size of that particular block. Here the size of particular block is equals to the node size. What is the type of node? Struct node. So size of is an operator which gives the size of a particular argument. So size of struct node. Okay. So I hope it is readable to you. Struct node. Struct node size of, okay, I write it over here. P is equals to, here we need to type typecast, then malloc, then size of, then struct node. Okay, so this particular malloc function reserve the size of that struct node type. We need to typecast it, and we need to typecast it in the structure pointer. So I simply write struct node star. So it malloc function return the address of that particular reserved block, and this one make typecast to the according to the pointer, and that address is occupied by the p. So it is simply used to declare a single node of a particular linked list. So today we discuss about the dynamic memory management function in the C programming language and how we create the node. The next video we are going to implement all the code of creating the simply linked list and insertion operation in the simply link. Thank you very much.